Today we are going to learn two rules for simplifying algebraic expressions. The first one is called the product of powers rule. And in general terms, here's what it says. When you take a letter to an exponent and you multiply the same base to a different exponent, you are going to keep the base and add the exponents. So let's see how that looks in practice. Your learning target is, I can use the rules for multiplying monomials to correctly evaluate or simplify expressions. So here we have two monomials that have the same base. And so we want to multiply them. And in order to get this idea in our head, we're going to go back to the basics. So 7 to the third means I have a base, 7. And it is multiplied by itself 3 times. Once, twice, 3 times. This is 7 to the third. Similarly, 7 to the fifth means that I have 1, 2, 3, 4, 5 sevens all multiplied together. And it says I am going to multiply those things, this monomial times this monomial. Well, it looks like 7 is being repeatedly multiplied the whole time, so it is going to remain my base. And then I just have to count up how many 7s are being multiplied. 1, 2, 3, 4, 5, 6, 7, 8. 7 to the 8th power. That follows what my rule says. It says if I have the same base, 7, keep it, and add my exponents to get my new exponent. In this spot, I want you to evaluate. You can either use a calculator with an exponent function, or you can use Desmos.com. Please take 7 to the 8th power. Pause me while you do that, and come back for the answer. So I obviously did not write a big enough box because my answer comes out to be this. 5,764,801. We can use the same process even if we happen to have some letters. So if we go back to our basics, n to the 6th means I have a base n and I am multiplying it by itself 6 times. 1, 2, 3, 4, 5, 6. This is n to the 6th. I'm going to multiply that by n to the 9th. I'm going to have to move down a little bit so I have more space. But my base is n, and I'm multiplying it 9 times. One, 2, 3, 4, 5, 6, 7, 8, 9. And so my answer will be my base n is being repeatedly multiplied 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 times. Now if we look at my rule said if you have the same base, keep your base. Add your exponents to get your new exponent. Now I cannot evaluate this. This is as far as I can go with this one until I know what n equals. So let's make things just a tad bit harder. I still have two monomials. Notice when I have two sets of parentheses next door to each other, it implies that I am multiplying. So if you get stuck on something like this, my suggestion is to break it apart. In this first set of parentheses, I have a 5 and an A and an A. This is my first set of parentheses, 5a squared. And I am multiplying that by my second set of parentheses, which is a negative 3 and 1, 2, 3, 4 a's. This is negative 3a to the 4th. So if I were to take my numbers and multiply those, 5 times negative 3 is negative 15. And then if I just count up on my a's, a is being repeatedly multiplied 1, 2, 3, 4, 5, 6 times. There's my answer. So let's look up above. What I could have done is just multiply my numbers, kept my base, added my exponents, and I would have gotten the same answer. Okay, this one is all yours. I want you to pause me, work this out, and come back and check against my answer. Until you get good at this, I think you should probably break things apart. This is 3 times 4p's. Notice I'm multiplying. This is a negative 2 and 3p's. If I were to take my numbers together, 3 times negative 2 is negative 6. P is being repeatedly multiplied 1, 2, 3, 4, 5, 6, 7 times. There's my answer. Some of you are getting better at this and can just look at it and use the rule. 3 times negative 2, keep your base, add your exponents, and you would get the same answer. So let's switch out to the quotient of powers rule. This one says that if I have the same base and I am dividing, I'm going to keep my base and subtract my exponents. The learning target says I can use the rules for dividing monomials to correctly evaluate or simplify expressions. As you are beginning to learn these rules, I want you to go back to the basics. So 3 to the 9th means I have a 3, my base, multiplied 9 times. Let me make sure I counted right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. That division sign could be a fraction bar, which makes this my denominator. I have 3 multiplied by itself twice. And so all I did was I went back to the basics and I wrote everything out. Now I can simplify. I know that if I have the same thing on the top and the bottom of a fraction, they will cancel. These 3's cancel. Those 3's cancel. Which leaves me with a base of 3 multiplied by itself 1, 2, 3, 4, 5, 6, 7 times. Because I have just numbers, I can absolutely evaluate that. You can either use Desmos or a calculator that happens to have an exponent key. 3 to the 7th power, 2,187. Now I'm sure some of you are catching on to this exponent rule, so let's look at it. If I have a monomial with the same base, keep your base. And when you're dividing, subtract your exponents. 9 minus 2 made 7. I can follow the same process even if I only have letters. So I have x to the 8th. 1, 2, 3, 4, 5, 6, 7, 8. My division sign could be a fraction bar, which gives me a denominator of 1, 2, 3 x's. I can cancel if I have the same thing numerator and denominator. So I am going to change colors and I can cancel, 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 cancel. And my answer is I have x repeatedly multiplied 1, 2, 3, 4, 5 times. For those of you who are catching on to the rule, I kept my base, x, and I subtracted my exponents. 8 minus 3 is 5. And I can't evaluate this. That's as far as I can go until I know how much x equals. So let's try this with some monomials that are a little more complex. So here I have 16 and 4 n's on top. This is a fraction bar. And then I have 18 and 2 n's on the bottom. First, we need to simplify what is 16 over 18 in simplest form. Well, I know they both can be divided by 2. So if I do that, I come up with 8 over 9. And then I can start canceling. N on top, N on the bottom, N on top, N on the bottom. And I'm left with 2 n's on top. So I'm just going to extend my fraction bar. My answer could look like this, or it's totally okay to have your answer look like this. Either one is fine. That's as far as I can go until I know what my variables stand for. So, if you were following the rule, you would have had 16 divided by 18, which in this case came out to be a fraction in simplest form. I kept my n as my base. I subtracted my exponents. 4 minus 2 is 2. Okay, this one is all you. I want you to work this one out, and when you have an answer, I want you to come back. All right, so in my numerator, I have 4 and 5 n's. 3, 4, 5. This can be a fraction bar. And I have 6 and 2 n's on the bottom. So first, let's simplify 4 over 6. We'll simplify to 2 over 3. Then I'm going to cancel, 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 cancel. And I can either put my n to the third power in my numerator, or if that looks messy to you, you can just stick it off to the side. There are my answers.